fraction. Hello from West Virginia. I really got to figure this out. All right, but what I can figure out, what I've got down is joke of the day, because it is the best part of the day. So let's take a look at adding and subtracting mixed numbers. We know how to add and subtract fractions that have common denominators and fractions that have uncommon or unlike denominators. We're going to use that idea in order to be able to add and subtract mixed numbers. Now there's a couple of ways of attacking adding and subtracting mixed numbers. One way is to say, you know what, I know what to do with fractions. So what I'm going to do is I'm going to convert all of my mixed numbers into improper fractions. And then once I've got those improper fractions, I'm going to go back to those rules that I know for adding and subtracting fractions. I'm going to get that common denominator if it's necessary. I might already have a common denominator and I can just carry on with life. But if I don't have that common denominator, I'm going to get the common denominator, lovingly call that LCD, and then I'm going to follow those common denominator rules for fractions. Most people like this method because it piggybacks on something that they already know. And we all like to go back to things that we're already familiar with and already very good at. So this is a very well-loved method. The only problem with this method is oftentimes when we convert them to improper fractions, we create fractions with very large numbers that become very cumbersome to deal with. So the way to combat those very large numbers is to do what I would call method 2. What method 2 does is it says, you know what, remember, a mixed number is a whole number part and a fractional part. What that indicates is I've got an addition problem basically. And addition is commutative and you can add any way you want. So if that's the case, then I could group up the whole number parts and I could just go ahead and combine them, whether it be by adding or subtracting. And then I can group up the fractional parts and combine them, whether it be by adding or subtracting, combine the fractional parts. I just have to be careful because once again, I still have to get those common denominators, perhaps, but I know how to do that. That's not that difficult anymore. The only struggle that I'm going to run into is if I am subtracting, sometimes in those fractional parts, there won't be enough to subtract from the first fraction. If that's the case, then what I'll have to do is I'll have to borrow from that first whole number in order to create a fraction large enough to subtract from it. Now I know this is all probably just swirling around in your brain. You're going, what is she even talking about? I have no idea. So let's take a look at some examples and I'll run through both methods in these examples to make sure that we feel very comfortable. Now you don't have to know both of these examples. I'm just going to show you, or both of these methods, I'm sorry. I'm just going to show you both of them so that you can see the differences and the benefits to each method and you can decide which method you want to use. You settle into the one that's comfortable for you. So let's say that I've got the example of 8 1/3 plus 1 1/3. Again, remember, hear those words, 8 1/3. In other words, 8 whole pieces and a third of another piece. But then I'm adding to that pile one whole piece and another third of a next piece. So my first method said, well, I can convert each of these to improper fractions and just go with those fraction rules that I know. If I'm going to do that, we learned that that means I'm going to multiply these two together. 8 times 3 is 24. And then I'm going to add this one up here. So 24 plus 1 will give me 25 thirds. And then what I'm going to do is do the same idea here and convert this one. Multiply here. 3 times 1 is 3. Plus 1 gives me 4. So I'm going to take my 25 thirds and I'm going to add 4 thirds. Now I'm going to go back to those fraction rules that say if I have a common denominator, keep that denominator because it is the superhero of fractions. I don't want to mess that up. So I'm going to keep my superhero of 3 and I'm going to add those numerators. And a 25 plus a 4 is a 29. But now what I'm going to do is I'm going to simplify my fraction if I can. Remember, that means I'm going to look for a number that will go into both of these. Is there a number that will divide into a 29 and a 3? Nope, there is no number that will divide into both of those. So this is simplified. However, since I started with mixed numbers, I definitely need to end with mixed numbers. You may have noticed in the previous video that I said, well, sometimes you need to take your improper fraction and turn it into a mixed number, sometimes you don't. And it just depends on what the directions say. But if you start with mixed numbers, you most definitely need to end with a mixed number. So I'm going to divide up. 3 goes into 29 7 times with a remainder of 2. And that remainder I'm going to put over my divisor of 3. So 29 over 3 is the same thing as, 3 goes to 29 9 times. I apologize. With a remainder of 2. And now I'm double checking. That's how I caught it. 9 times 3 is 27. 27 plus 2 is 29. So 29 over 3 is the same thing as 9 over 2/3. Or 9 and 2/3, I'm sorry. Now, let's take a look at that second method. Here's where it gets interesting. Remember I said that your mixed number is really the idea of an addition problem. Because if you hear those words carefully, this says 8 and 1/3. So it's like saying I have 8 whole pieces, 1, 2, 3, 4, 5, 6, 7, 8, and a third. I'm going to add in that pile 1 whole piece and another third. Now remember, since it's one great big huge addition problem, and addition is commutative and associative, that means I could put these whole pieces together. I could take these whole pieces and I could put them together with this whole piece because I'm just throwing them all in one pile. That's all I'm doing. So I could put the 8 whole pieces together with the 1 whole piece, giving me 9 whole pieces. And then if I'm just throwing them into the pile, that means I could put these 2/3 pieces together in the pile as 2/3. So I can get straight to that 9 and 2/3 without having to turn them into impropers, without having to do the conversion from an improper into a mixed number. I can just simply utilize the idea that this is 8 and a third plus 1 and a third. And since that addition is commutative, I could put the whole number parts together and I could put the fractional parts together. So that I get 8 plus 1 will give me 9, and a third plus a third will give me 2/3. So hopefully now the 2 different methods is a little less confusing. And like I said, you don't have to know both. You settle into the one that you're comfortable with and you go with that. But let's practice with it some more so that you can get comfortable with it. Notice in this method it says I have 10 and 3/8 minus 6 and 1/8. So I already have in my pile in front of me 10 whole items and 3/8 of another item. I'm taking out of that pile. I'm not adding into the pile. I'm taking out of the pile 6 whole items and an 1/8. Well, that first method, recall, it said that I'm going to convert them to impropers. So I'm going to multiply here and add here. 8 times 10 is 80. Plus 3 is 83, so I have 83/8. And then I'm going to convert here as well. Multiply here. 6 times 8 is 48. Plus the 1 is 49. So now what this tells me is in my pile, I have 83 of these 8 pieces. I have these 8 pieces. There are 83 of them sitting there. I'm taking out 49 of them. When I take out 49 of those 8 pieces, that's going to leave me with 34 of the 8 pieces. Now, I always simplify if I can. Is there a number that will go into both 34 and 8? Yes, they're both divisible by 2, so most definitely that. 2 goes into 34 17 times. 2 goes into 8 4 times. And like I said before, if you start with a mixed number, most definitely end with a mixed number. So I'm going to divide up. 4 goes into 17 4 times. With the remainder of 1, I'm going to put that remainder over its common denominator divisor, so I get 4 1/4. Now, let's take a look at method 2. Hopefully you will see how beautiful method 2 is, because look how large these numbers were. Method 2 is going to be beautiful because the numbers are not going to be as big. Notice it says that I start with 10 whole pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then I also have 3 of these 8 pieces. This is what I'm starting with in my pile. But it says, now what I'm going to do is I'm going to take out of the pile 6 of those whole pieces and 1 of the 8ths. Well, I can easily take 1 of the 8ths out, and that's not a problem at all. It's gone. And I can also take out 6 of those whole pieces. 1, 2, 3, 4, 5, 6. And so I am left with 4 and 2/8. But we know that 2 and 8 are both divisible by 2. 2 goes into 2 once, 2 goes into 8 4 times, giving me yet again my 4 1/4. Because 1/8 certainly is the equivalent of 1/4. So again, the idea is I can take these whole number parts and I can go ahead and subtract them. 10 minus 6 will give me 4. I can take those fractional parts, 3/8, and I can take out the 8, giving me 2/8, and then just simplify my fraction. Okay, like I said, I want us to get really comfortable with this, so let's practice with some more examples. I'm going to get these out of the way so that we can work a little bit better with this, and let me clear this board for us. Pardon me, enjoy that scenery there while we get this out of the way, putting up a couple new examples for us. Okay. This time what we're going to do is we're going to take 4 2/7 and we are going to subtract 1 5/7. Now, like I said before, method 1, what method 1 says is I'm going to convert these to impropers. So I'm going to multiply here and add here. 4 times 7 is 28. 28 and 2 is going to be 30. So I have 37ths. And I'm going to convert here. Multiply here. 1 times 7 is 7. Plus that 5 will give me 12. So I have 37ths minus 12/7. Well, if I have 37ths and I take out 12 of them, that leaves me with 18/7. Now, once again, I do need to simplify. Is there a number that will go into both of those? Absolutely not. So I'm going to convert it to a mixed number because I started with mixed numbers. And once again, if you start with a mixed number, you definitely need to end with a mixed number. So I'm going to divide up, and 7 goes into 18 2 times with a remainder of 4. And I'm going to keep that superhero of fractions, that common denominator of 7. And that's how I get 2 4/7. So let's take a look at that second method. Now here's where the second method gets a little bit hairy. Here's where some people who used to love the second method, they were big fans of the second method, suddenly they don't like it anymore in a situation like this, understandably so. So remember, it says I'm going to take those whole numbers and I'm going to subtract them. Easy enough, that gives me 3. But then I'm going to take those fractional parts and I'm going to subtract them. The problem is, if I have 2/7 in my pile, I can't take 5 out. I don't have 5. So what I have to do is I have to take a look at this idea of these 4 and then the 2/7. 1, 2, 3, oops, 2/7, I'm sorry. These 4 and 2/7. To be able to take 5/7 out of there, I need to break one of these down into 7ths. So that idea is the idea of borrowing. I'm going to convert this into 1, 2, 3, 4, 5, 6, 7. I'm not very good at that. But now I have 3 and 9/7. Well, if I have 9/7, I certainly can take 5/7 out of it. So the crux of that second method, like I said before, notice in those steps, I said, well, if you're subtracting, you might need to borrow from that first whole number because you might not have enough to subtract those fractional parts. So if that's the case, and I can see right away from the very beginning that I cannot take 5/7 from 2/7, it's not going to happen. So that tells me, okay, I need to do a little bit of borrowing. So I'm going to borrow from that 4. Let's write it down here. 4 and 2/7 minus 1 and 5/7. I'm going to borrow from this 4, turn it into 3, but remember I'm borrowing 7/7. So when I take that 7/7 and add it to the 2/7, that gives me 3 and 9/7. Now I can take away 1 and 5/7. I can subtract it. Because now I can say my whole number parts, 3 minus 1, will give me 2, which is right here. And my fractional parts, 9/7 minus 5/7, will give me 4/7, like I saw right up there. So it does work. So like I said, some people really love that second method when the numbers are easy and you don't have to borrow. But some people that really kind of messes it up, it scares them. And so they say, well, I want to stick to method 1 and just work with those impropers. So now let's take a look at an example of what happens whenever you don't have that common denominator. Because like I said, I want us to get really good at this. And the only difference, quite frankly, when you don't have that common denominator is just the need to get the common denominator. So let's take a look then at, and I'm on example D here, a 5 and 5/6 plus a 2 and 1/10. So if I'm going to work with method 1 that says, let's go ahead and just convert them to impropers, then that means I'm going to multiply here. 5 times 6 is 30, plus the 5 is 35/6. And I'm going to multiply here. 2 times 10 is 20, plus the 1 is 21. And now I need to get a common denominator. Recall, common denominator is the smallest number both of these will go into. I don't necessarily have to multiply the two together. I just want the smallest number they'll both go into. Well, both of them will go into 60 definitely, but is there a number smaller? 10 will go into 20, but 6 won't. 10 will go into 30, 6 will. So I'm going to convert each of these to 30ths. So that means I'm going to multiply this 10 by 3 and the 21 by 3 as well, giving me 63 30ths. I'm going to multiply the 6 by 5 and multiply the 35 by 5 as well, giving me a 175. Oh my goodness, my numbers are getting huge. This is getting a little unsettling. But I do have the common denominator, so I'm going to go ahead and combine those numerators, giving me a 238 over that common denominator of 30. I'm going to simplify my fraction. Both of them are divisible by 2. My denominator, 30 divided by 2, is 15. And my numerator, 238 divided by 2, is a 119. And now there is not a number that will go into both of these because 3 and 5 will go into 15, but 5 definitely won't go into 119, and 3 won't go into 119 either. So therefore, this is the best it's going to get, but I do need to convert it to a mixed number because I started with a mixed number. So I'm going to divide up, and 15 goes into 119 7 times with a remainder of 14. So I get 7 and 14/15. Now, like I said before, this is the beauty of that second method. Those numbers got enormous and they were very unsettling. Watch what happens with the second method. It flows pretty smoothly. Because the second method says, okay, this is 5 whole pieces plus 5/6 of another piece, plus 2 whole pieces plus 1/10 of another piece. So I can put my whole number parts together, and 5 plus 2 gives me 7. I can put my fractional parts together. Now with those fractional parts though, they do need that common denominator, but the numbers will be much easier to work with. Because if I take a look at 5/6 plus 1/10, once again the smallest number they'll both go into is definitely a 30, but the numbers are much smaller. The digits are smaller and easier to work with. Because 6 times 5 will still give me 30 just like up here, but notice I'm only multiplying 5 by 5, not 35 by 5. 5 times 5 is 25 instead of a 175. Now 10 times 3, just like before, will give me 30, but I'm not multiplying 21 times 3, just a 1 times 3 to give me a 3. Now when I add these two up, I get a 28 over 30, which still needs to simplify. Both of them are divisible by 2. 28 divided by 2 is 14. 30 divided by 2 is 15, giving me yet again that 17 and 14/15. So, as I've said before, you don't have to know both methods. You pick the method that you feel most comfortable with and you go with that. All right, like I said, let's just try a couple more examples to make sure we feel really comfortable with this. So we have 1 and 5/7 plus 4 and 2/3. Now remember, you decide which method you like. I'm going to continue to show you both methods. Just we have several examples of both methods, and you can settle into which one you're comfortable with. If I'm going to do that first method, remember that means I'm going to turn them into impropers. To turn them into impropers, I'm going to multiply here. 7 times 1 gives me 7, and then I'm going to add here. So 7 times 1 giving me 7, and then plus 5 will give me 12/7. And I'm going to do the same thing right here. I'm going to multiply 3 times 4 is 12. 12 plus 2 will give me 14. And now I need to turn them into common denominators. The smallest number that both a 7 and a 3 will go into is a 21. So I'm going to convert each one of them into 21sts, which means that I'm going to multiply this 7 by 3 and multiply that 12 by 3 as well. 12 times 3 will give me 36. Multiply this 3 by 7 and the 4 by 7. Now, not 4, but 14. 14 times 7 is going to be a 98. Notice that the numbers are getting kind of big, a little bit cumbersome here. I'm going to keep my common denominator because I worked awfully hard to get it. And then I'm going to add those numerators. A 36 plus a 98 is going to give me a 134. And now I'm going to attempt to simplify. Is there a number that will go into both 134 and 21? No, because 3 will go into 21, but 3 will not go into 134. 7 will go into 21, but 7 will not go into 134. So I'm left with converting it to a mixed number. That means I'm going to divide up, and 6 goes into 21. I'm kind of leading me into it. 21 goes into 134 6 times with a remainder of 8. And keep that common denominator we worked awfully hard to get. Now, once again, notice those numbers, big and cumbersome. This is where that second method is helpful. Because the second method says, okay, this 1 5/7 is the equivalent of 1 plus 5/7. And this 4 2/3 is the equivalent of 4 plus 2/3. And since addition is commutative, I can add these whole number parts. 4 plus 1 will give me 5. And I can add the fractional parts. So the 5/7 plus the 2/3 is going to be a bit easier to deal with than 12/7 and 14/3. Still yet, I have to get that common denominator. The smallest number that a 7 and a 3 will both go into is a 21. And 7 times 3 will give me a 21. 5 times 3 gives me a 15. 3 times 7 gives me a 21. 2 times 7 gives me 14. Notice much smaller numbers to deal with than a 36 and a 98. So now when I keep that common denominator of 21 because I worked really hard to get it, and I combine those numerators of 15 and a 14, it gives me a 29. Yet again, I do need to attempt to simplify. But that 3 and that 7 that go into 21 will not go into 29, but I am going to convert it into a mixed number by dividing up. 21 goes into 29 one time with a remainder of 8. But remember, this 1 and 8/21 is going to be combined with that 5. So yet again, I'm going to combine those whole number parts. 5 and 1 will give me 6. And I get my 6 and 8 over 21. Either method that you feel comfortable with, you go with that method. Just sometimes one method is easier than another. All right, just 2 more examples. Again, I just really like for us to see lots of examples so that we feel really comfortable with everything. Good and solid with it. So now let's take a look at, we've got 3 and 1/8 minus 2 and 1/4. Good, because we've not seen a subtraction problem. No, yeah, 2 and 1/4. We've not seen a subtraction problem yet. So let's go with that first method. And remember, the first method says, let's convert them to impropers. So I'll multiply here. 3 times 8 is 24, plus 1 will give me 25/8. And then I'll multiply here. 4 times 2 is 8, plus 1 gives me 9. And I'm going to subtract. But again, I need to have that common denominator. What's the smallest number that both the 8 and the 4 will go into? It's 8. The nice thing is this is already there, so I don't need to convert that at all. That helps. And now I'm going to convert this into 8s. Multiply this 4 by 2 and the 9 by 2 as well. So I've worked really hard to get this common denominator. I'm going to keep it because I've worked so hard to get it. And I'm just going to work those numerators. 25 minus 18 will give me 7. I'm left with a 7/8, which will not simplify. Now notice I don't need to turn it into a mixed number because it's not one of those top-heavy fractions. It's not an improper. So my 7/8 is perfectly fine, which again does not simplify. Now, granted, that was not hard at all, but let's just go ahead for good measure. Let's take a look at what method 2 will look like. So once again, method 2 says let's go with this idea that 3 and 1/8 is 3 plus 1/8. But here's where it gets a little bit tricky because this is a subtraction problem. I gotta be careful. I'm subtracting that 2 1/4. Couple of ways of looking at this. You can look at it as distributing that negative through, which would mean that 3 1/8, I'm going to take out the 2 and I'm going to take out the 1/4 as well. Here again, it's the idea of I'm going to work these whole numbers. 3 minus 2 gives me 1, and I'm going to work the fractional parts. So whether you distribute it through or not, you still need to look at this 1/8 taking out the 4th. So 1/8 minus 1/4. When I do that 1/8 minus 1/4, yet again, I need to get those common denominators. Just like before with an 8 and 4, the common denominator is an 8. This is already there. This is not. I'm going to multiply by 2 and multiply by 2, and I have a 2/8. Whoa! Here's where we have a problem. Because if I only have 1/8, I can't take 2/8 out. I don't have enough to take out. But recall, this is where we can do that borrowing idea. Because I cannot take 2/8 out, I can take this 3 1/8 and I can borrow from the 3, making it a 2. So when I borrow from that 3 and I make it a 2, then I'm going to take this 1/8, I'm going to add to it 8/8. So when I take that 8/8 and I add to it that 1/8, that gives me 2 9/8. Now I'm going to take my 2 9/8 and subtract 2 1/4. So once again, when I work those whole number parts, 2 minus 2 gives me no whole parts. I don't have any whole parts. Recall my answer being 7/8? I shouldn't have any whole parts. So this is making sense. So now what I'm going to do is take that 9/8 and I'm going to subtract out of that the 1/4. Yet again, the common denominator of 8. So I have 9/8 minus that 2/8, because remember 1/4 converts to 2/8. But now that I have 9 of those 8s, I can take out 2 of those 8s. And that will give me 7/8, which is the same answer that I had before. So recall just a little bit on the second method, because a lot of people get kind of worn down by that one. Remember, if I go ahead and convert these to common denominators from the very beginning, this 1/8 and this 2/8, I can see right away I'm not going to be able to take 2/8 out of 1/8. I need to borrow from the 3. So that converts this into 2 whole parts. Adding 8/8 to 1/8 gives me 2 9/8. Now I can take that 2 9/8, I can take out 2 1/4, because I can take 2 whole parts from the 2 whole parts. When I take 9/8 minus 1/4, which is 2/8, that leaves me with 7/8. All right, one last example, and that will wrap this up for us. You'll find this last example is actually pretty easy, either method that you've got. But I just want to show you this last example because a lot of people get settled into the idea this is going to be hard, it's going to have a lot of steps. And I want you to see in this last example, no, not always. So I have 8 4/5 minus 3. No fractions with it, just a 3. So if I'm going to do that first method, remember that first method says get those common denominators and, well, actually convert them to impropers. So I'm going to multiply here. 8 times 5 is 40. I'm going to add here, giving me 44 over 5. And now that's like a 3 over 1. And now when I get those common denominators, the smallest number that both a 5 and a 1 will go into is just a 5. So 44 over 5 is there. Good. I don't want that to get any bigger. I'm going to multiply this by 5 and this by 5 as well, giving me 15/5. So I worked really hard to get that common denominator. I'm going to keep it. And I'm going to subtract those numerators. 44 minus 15 will give me a 29. There is not a number that will go into both 29 and 5, because only 5 will go into 5 and it won't go into 29. So I'm ready to convert this to a mixed number and divide up. 5 goes into 29 5 times with a remainder of 4. So I get 5 4/5. Watch the beauty of this second method though. That wasn't too bad. But watch how beautiful the second method is. Remember, 8 4/5 indicates 8 whole pieces plus a fraction of another piece. I'm going to take out of that 3 whole pieces. Well, if I have 8 whole pieces and take 3 whole pieces out, I'm left with 5 whole pieces. The fractional part, I'm not taking anything out of it. So I'm left with 5 4/5, just like I had before. So hopefully this helps you to understand how to add and subtract mixed numbers, whether you have common denominators or not common denominators. And as you can see, you have 2 methods to go with it. You don't have to know both methods. You settle into the one you're comfortable with. That first method says, let's go back to impropers, because I know what to do with impropers. The only problem is you might get some very large numbers, large digits that'll be a little bit difficult to work with. The second method is beautiful because it makes those digits a little bit smaller, easier to work with, because you combine the whole number parts, you combine the fractional parts. You just have to be careful. If you are subtracting, you might need to borrow, and that's the part that tends to confuse people. But if you understand that you're borrowing fractional pieces, and for instance, if you're borrowing and you're turning it into eighths, you're going to borrow 8 eighths. If you're borrowing tenths, you're borrowing 10 tenths. And then adding it to the fractional part that you already have, then this is a great method. It kind of goes quick and easy. So I hope that helps. Have a great day.